Hello, and welcome to this course in defining your own functions in Python. If you've reached a point in your own programming in Python where you've started to use other functions and you're wanting to learn a little bit more about them, and especially how to write them, then this course is exactly what you need. In this course, we will take a look at what functions are and why they're useful. We'll talk about the difference between defining a function and calling a function. We'll spend a lot of time taking a look at how information is passed to and from a function through argument passing and the return statement. And then we'll spend a lot of time taking a look at some of the features Python provides to really specialize how you provide arguments to a Python function. And then lastly, we will take a look at how you can let other programmers know how to use your function. So the goals for this course: after this course, you will know how functions work in Python and why they're beneficial. You'll learn how to define and call your own Python functions. You'll learn a lot of mechanisms for passing arguments to your function and how to return data from your function back to the calling environment. I'm Howard. I'm excited to be leading you through this course, and we will start with just taking a general look at functions in Python. So let's begin by taking a general look at functions in Python. A function is a self-contained block of code that's designed to perform a specific task or related group of tasks. Some functions that you've probably encountered already might be the ID function, the len function, the any function. Basically, any name that you've used followed by parentheses, either with something in them or not, is a reference to a function that someone else has written. When you use a function, which we call invoking or calling a function, you only need to know its interface. Its interface consists of what arguments, if any, are passed to the function, and what value or values, if any, that it returns. When you make a function call, you provide the function name and then supply appropriate values for the arguments that are expected. Then the function carries out its task. You don't need to know how that's done. You just need to know what it's supposed to do when it's finished. When it is finished, it returns to the spot in your program where you called the function, and then use, if needed, any of the data that it returned. On the other hand, if you are writing a function, you determine how it performs its task. That part we call the implementation. You decide exactly what it's going to do to carry out the steps necessary to accomplish whatever that function is supposed to do. And then when you call your function, it's just like calling any other function. You supply the appropriate argument values. Your function then performs its task on those values if it uses any. Then the program returns to the exact spot where you called your function, where, if needed, you should use any data that was returned. Next, we'll take a look at why you would want to write a function. So now let's take a look at some of the reasons you would want to write a Python function. Almost every programming language supports user-written functions. They may be called something different: subroutines, procedures, methods, subprograms, and of course, functions. They're that useful. But why have them? Well, one reason would be for abstraction and reusability. Suppose you've written a really useful section of code, something you're probably going to want to use again. How would you reuse it? Well, the first thought might be to just copy and paste it. A problem with that is that the names may be different in each new place you use it. So you'd have to change all of the variable names or whatever other references it used. And then suppose you find a better way to perform that task. Now you have to go back and make that change everywhere that you're using that particular section of code. So perhaps this might not be the most efficient way to reuse code. The answer is to define a Python function to perform that task. Every time you need to use it, you simply call it. And if you need to make a change to it, you only need to change the function the one time. And then everywhere where that function is used, it will use that new version. Each time you call it, you would provide the argument values needed for each particular call. We refer to this as the abstraction of functionality, the idea of don't repeat yourself. A second reason we might write a function is for modularity. Modularity allows you to take a complex process and break it down into smaller steps. Suppose, for example, you had a program that was going to read data from a file, process that data in some way, and then save that processed information back to another file. So your program might look like this. Have a section of code to read the file, a section of code to process the file, and a section of code to write the file back out. That's a lot to look at in one particular unit. It's going to be tough to solve problems in a program doing this many things at once. A better solution would be to take each of these segments and write a function to perform that task. Create a function to just read the data, and whatever steps are there, go in that function. Create another function to process the data, and whatever instructions were involved there would go in that function. And then another function to save that data back to a file with its related statements. And then your main program looks much cleaner. You simply call each of the functions. Now, this is kind of an abstract example. You might actually need arguments passed and return values saved to actually coordinate what happens from one function to the next. But this is just to give you a look at how much cleaner this program is when we break it down into these steps. Easier to solve problems during the debugging stage and testing stage when your program is broken down into pieces like this. Another reason to use functions is that they provide namespace separation. A namespace is a region where an identifier, variable of some kind, has meaning. This is often also referred to in some programming languages as the scope of an identifier. A Python function creates its own namespace. So any names, any identifiers, any variables that you create within that function are limited to that particular function's use. So you can always use the best variable name or the best identifier name for an object and don't have to worry about some other function somewhere else in the program also trying to use that same name. You'll learn more about namespaces further along in this particular series. Next, we will take a closer look at function calls and definitions. Now let's take a look at function calls and definitions. To call a function, to use a function or invoking, other terms that we use, you simply give the name of the function and then followed in parentheses, argument values, if any, that are needed. Even if the function doesn't take any arguments, you still have to have the parentheses. You've probably seen this before, using built-in functions or functions from modules you've imported. For example, print hello is a function call. We use the word print, the name of the function, and then in parentheses, we provide an argument, in this case, what we want printed, that the print function is expecting. Now let's take a look at a function definition. This is the syntax for defining a function. It begins with the keyword def. This tells Python that you are about to define a function. Next is the function name. And we don't use these angle brackets. These are just syntax notation to indicate that you would replace the function name in this description with an actual name. The name of the function should describe what it's supposed to do so that someone using your function knows what to expect when they use it. Following the function name are parameters. These are the identifiers that will hold on to argument values that the function is given. If the function doesn't take any parameters, you would still use empty parentheses. And if you have multiple parameters, they would be separated by a comma. And we will see a lot more about the use of parameters in the next few lessons. And then the header line is concluded with a colon. What follows is one or more statements indented which carry out the task that this function is supposed to perform. Your really useful piece of code that you wrote, here's where those instructions would be written down. And again, you do want to indent them. That's how Python knows the code that you're typing is part of that function definition. So here's a real simple example of a Python file that contains a function and uses that function. I've called this file function call.py just to show us what a typical function definition and function call would look like. We begin with the word def, followed by the name of the function, f, nice arbitrary name for an arbitrary function. This takes no parameters, so we have an empty set of parentheses, and then the colon to indicate that this is the conclusion of the header line for this function, and what follows is going to be the statements we want the function to execute. The statements are indented, and that's what tells Python that they are part of this function definition. In this particular case, we're going to do two things. We're going to define a variable s, which is going to contain a string, and then we're going to print the value of that string variable. And here we just have a print statement to indicate that we are currently inside the running of this function. Line 5 is not indented, and so this tells Python that this is not part of the function. And so if I were to run this Python file, we would first have our function definition, but these statements wouldn't be executed until we actually have a reference to call that function. So this Python program will start running at line 5, where we have a print statement to say where we are in the execution of this program, and we're in the part before we've called our function. Then we're going to call our function. And what happens is Python is going to pause the running of these 3 lines, come up here, and execute the statements of the function we just wrote. In this case, it's going to display an output statement saying that we are currently in the process of executing this function. When this function is finished, program execution returns to where the function was called, which was line 6. We finished line 6, and so we're going to see the print statement in line 7 will be executed last. Let's take a look at that. So let's just run this. So this was function call.py, and the behavior is going to be exactly what we expected. The first line that's executed isn't within the function, but it's the first statement outside of the function, which was before calling f. Then inside the function, the output statement occurred, and then the function finished its execution, and we returned to line 7 and had that output statement. Let's see if I can put these side by side so you can see that a little bit better. There. Line 5 executed. Line 6 called our function. We defined this variable. We printed out its value. Then program execution returned to line 7, and we got the after calling f output statement. Sometimes in program design, you know that you need a function in a particular place, and you want to make sure the function is called correctly and that program execution returns to after it's called, but you're not actually ready to write the body of that particular function. We call that a function stub. It's a placeholder function. We know we need a function f. We don't know what we want it to do exactly just yet, but we need to have it defined as a name so that other parts of the program we can check and make sure are working. To create a function stub in Python, you simply give the statement pass as the body of the function. And that simply indicates we're not going to do anything, but it allows us to write a function stub with a function body of some type. The next series of lessons are going to be on argument passing. Python has many, many ways to provide arguments to a function when you call it. And the next series of lessons will take a look at many of those methods for passing arguments to a function. Next, we'll take a look at a way to give functions a little bit more flexibility, and that's through argument passing. Argument passing allows you to provide data for the function to use. That way, the function won't always run the exact same way each time. The function's behavior can vary from one invocation to the next. You wouldn't want the print function, for example, to always print out the same thing. We provided an argument to describe exactly what it is we want printed each time. The most straightforward way to provide argument values to a function is through positional arguments. These are also called required arguments, and we'll see other types of arguments in some upcoming lessons. You specify that a function will take positional arguments through a comma-separated parameter list in the function header. And then these parameter variables will be given values when the function is called. I'll be defining this function in my REPL. You can define functions interactively or in files. And this is a simple function that I will just create within my interactive environment. So you begin a function with the word def and then a function name. Now, throughout this course, I'm going to use the very boring function name f for just about every function that we take a look at. When you're writing a meaningful function, you want to give it a meaningful name that describes what it does. But here we're looking at the structure of functions. And so we're just going to use an arbitrary letter for each of the new functions that we create. The author of the companion tutorial that this relates to also does the same thing. Now, the inner C programmer in me wants to call all of these arbitrary functions foo, but the author of the article uses the word foo for something else, and I'll be following that as well in this course. So we'll just use the letter F to stand for a function, but keep in mind that a meaningful function should have a meaningful name. But here I want to specify that this function needs argument values to work. And in this particular case, I want to specify 3. And so we're going to specify that through parameter names. We're going to call the first one QTY to represent some quantity of something. The second one we're going to call item. And the third one we're going to call price. So when I use this function, I'm going to have to give it 3 argument values. One to represent quantity, one to represent item, and one to represent price. In the body of my function, quantity, item, and price become variable names that I can use. However, I would use other variable names once I know they have a value. In this particular case, I just want to print out the statement that indicates how much something costs. So we're going to use a print statement, and I'm going to use something called an F string to format this output. And I'll describe what I'm doing as I type it. But for more information on F strings, you should check one of the links down below this video. But an F string allows me to specify how variable values should be displayed inside of a string. So the first thing I want is the very beginning of this output, I want the quantity displayed. So I put that in braces. And when this function runs, whatever value has been given for quantity is going to be displayed at the very beginning of this string. Following a space, I want to display the value of item. And so I put the variable name item in braces. And then to complete my sentence, I want to say how much this all will cost. Now for price, I'm going to do something a little bit different. We're used to prices having exactly 2 decimal digits. And there's no way to guarantee that that's going to be provided for us when argument values are given in the function call. So the F string allows me to specify that using a formatting code of dot to F. And what that means is I want a fixed number of decimal digits, specifically 2. So no matter what value is given for price, it's going to be rounded to 2 decimal places. So there's the brace that closes the location for where I want price. There's the quote that ends my string literal with the additional F string formatting features. And there is the closing parentheses. Notice how this line was already indented for me. Your interactive environment will probably do that. as well as most editors will indent 4 spaces for the body of your function. Since this is all that I want to happen, on the next line, I'm just going to hit enter on a blank line, and that defines my function. So now I have a function f that I can use, and it's going to display information about how much so many of a particular item costs. So let's do a function call. To call a function, you specify the name, and then in parentheses, you're going to specify values that you would like each of the parameters to have. So for example, quantity, in this case, let's just say 6. For item, let's use the string banana, and we'll say that they cost 174. So now when this function executes, the variable quantity is going to have the value 6. The variable item is going to have the value banana, and the variable price is going to have the value 174. And those values will be used in the body of the function, which in this case is to simply display how many and what items we have and how much they cost. And so we get that 6 banana. I should have typed bananas. I'll do that next time. Cost 174. These are referred to as positional arguments because the order in which you specify the values matter. If I want to say bananas 6 and then 174, bananas is going to be used for quantity, 6 is going to be used for item, and 174 is going to be used for price because that's the position that those argument values were given in. And so we get banana 6 costs 174. Not sure that makes sense. Depending on how your function is used, putting parameter values in the wrong or unexpected order could actually cause an error. For example, if I say f and then say 6 and then 174 and then bananas, I'm actually going to get an error message this time because the body of the function was expecting price to be something that could be rounded to do decimal places. And a string literal cannot be rounded to 2 decimal places. And so in this particular case, putting the argument values in the wrong order, in the wrong position, actually caused the function to crash. Because this function has named 3 parameters, I have to provide it 3 argument values. So for example, if I leave off one of the arguments, I will get an error indicating that the function was expecting one more positional argument. If I specify too many, I'll also get an error. 4 arguments were given, but f only takes 3. Next, we'll talk about another way to provide arguments, and that's through keyword arguments. In the last lesson, we looked at how to use position arguments to provide values to the parameters of a function. In this lesson, we're going to take a look at using keyword arguments to provide values to those same parameters. When you call a function, instead of just providing a value, you can use the notation name equals value, where name is the name of the parameter and the value is the expression or value you would like that specific parameter to have. In doing this, you no longer need to maintain the order of the parameters that were given in the header of the function definition. Since you're specifying each one by name, Python will know which argument to use for each parameter. So let's use the same function from the last lesson. And now let's take a look at using keyword arguments to specify values. So again, I begin with the function call, but now I want to say quantity equals 6. I want to say item equals bananas. And I want to say price equals 174. So I'm being very explicit about which value I want for each parameter. And if I do that, I don't necessarily need to keep the parameters in the same order. Because I am, again, specifying what I want the value of price to be. I'm specifying what I want the value of quantity to be. And I'm specifying what I want the value of item to be. So when we make this function call, the appropriate values are used for their respective parameters, and the function behaves the way it should. You still have to be mindful of the number of parameters a function is expecting. You have to be mindful of the actual names of the parameters. So for example, if I say quantity equals 6, item is bananas, and I say cost equals 174, I'm going to get an error message because there is no parameter cost. There's a parameter price, and in our minds, price and cost are roughly the same thing. But Python just sees this as an identifier, and it looks at the name cost, and it doesn't have a parameter named cost up here, so it doesn't know what to do with that. And again, if you leave out a parameter, if I don't specify a value for price, I'll get that same error message that price was not provided a value. You can mix the use of positional arguments and keyword arguments. However, when you do so, the positional arguments must come first. So I could say 6 is going to be the value for quantity. And then I could say price equals 174 and item equals bananas. And everything works. And again, the order in which I would say the values for price and item using keyword arguments would not matter. Once I use a keyword argument, I then cannot go back and use a positional argument. So once I start using keyword arguments, I must do that to completion. We get an error that we can't call it that way. So if I want to do this correctly, I have to say price equals, and then it's going to let me do that. Once you have the notion of keyword arguments as a mechanism for specifying parameter values, you, as the author of a function, can start being a bit more creative. One of the things that you can do is to define default values for some of your parameters, and we'll take a look at that next.